Think about yourself for a second. Your physicality, your emotions, your personality. You're able to recognize all of these aspects in a matter of seconds. You can even detect others' mental aspects by just hanging around them for a couple of minutes. But a small percentage of the human population cannot recognize these emotions. This is widely caused by disorders such as autism or Asperger's syndrome. You may be fortunate enough to be able to accurately gauge emotion, but many people cannot do so, resulting in spoiled relationships, opportunities, and lives. With more than 1 million cases of both disorders in the US alone, something has to be put in place to help them, and the current solutions are hard to guarantee concrete results. Introducing Decode, an extremely versatile program that can be used in a multitude of places for daily use, helping those affected notice and interpret emotions. Using Decode, the user is able to clearly and accurately identify the other party's emotions.
Decode can be paired with a Google Glass to capture the facial expressions of the other person. It can then instantaneously determine the emotion and display it to the wearer. This removes the need of taking out your phone to keep track of everyone's emotions, and instead it supplies information to you right in front of your eyes. We are using a deep learning AI model to detect the face and then to identify the precise emotions. Using a CNN or convolutional neural network, we are able to highlight and take advantage of its innate advantages, such as its ability to downscale images and spatial coherence, which suits image classification very well. First, as you can see, we use various Keras APIs from the Atom activator to categorical cross-entropy, which helps optimize the loss function. Next, after reshaping the input parameters, we build our neural network using multiple 2D convolutional layers along with many pooling layers. We chose to use max pooling since it is the most suitable for image classification due to its translational invariance. It works by extracting the highest value input parameter from a pixel grid of the image, for example like a 3x3 grid. This decreases the number of input parameters, which speeds up training, testing, and also is more resistant to image noise. By using the rectified linear activation function or ReLU along with the softmax activation function, we can prevent saturation along with having output probabilities for each emotion. Lastly, we write the files for the weights and the model configurations. We use an online example as a framework of this code. However, to further enhance it, we then tuned the model for maximum accuracy, increasing the number of epochs to minimize loss, decreasing the stride of pooling layers from 2 to 1 to retain more small details, and slightly decrease the dropout to maximum accuracy. Although some of these steps may lead to overfitting, our tests have been pretty successful so far. With this CNN model, we are able to reliably recognize emotion and greatly benefit people with those disorders. Finally, let's take a look at this model in action. As you can see, our model can display a wide variety of emotions, from happiness to sadness to even surprise.
Millions in the world population experience emotional recognition problems. Decode can significantly lessen the burden of broken relationships and connections for people with autism or Asperger's syndrome. By allowing them to accurately gauge emotions while helping them interpret each emotion through our website, Decode can simplify a multitude of person-to-person interactions every single day.